Here's the first guided worksheet for week 2, section 1.3 on models and applications. In this section, we'll take a look at some word problems involving linear equations, and then we'll take a look at equations in which we'll have to solve for a certain variable. So for this first part, we'll take a look at problem solving with linear equations. What we'll do is we'll have a scenario, and we need to come up with a mathematical model that represents that scenario or real world situation. Here are some general kind of common sense steps we'll use in solving word problems. It's probably nothing new to you, but it's just kind of a reminder and a reiteration of how we're going to proceed through each of these problems. In a problem, we'll have some unknown quantities. So we can let x, or even some other variable we'll see later, represent one unknown quantity. And then with the rest of the information in the problem, we're going to represent the other unknown quantity in terms of x. So it'll be some expression involving x. Then what we'll do is we'll write an equation involving the variable x that models the information that's given. We'll solve it for x, answer the question, maybe write a sentence or two, and then just to kind of check to make sure your solution makes sense in the context of the problem. Maybe that your numbers aren't too big or too small, that idea. All right, so here's the first problem that we'll deal with. Problem 1 says the median starting salary of a computer science major exceeds that of an education major by $21,000. The median starting salary of an economics major exceeds that of an education major by $14,000. Combined, their median starting salaries are $140,000. Our problem here is to determine the median starting salaries for each of those three majors. Okay, well, in reading the problem, everything, I should say the salaries for each of the other majors that are not education majors are based on whatever the salary of the education major is. So a good starting point would to let X be the median starting salary of an education major. Then we can write the median starting salary of a computer science major as X plus 21, and the median starting salary of an economics major is X plus 14. Combined, so we basically used everything in the first two sentences. Taking a look at the last sentence then, it says combined, their median starting salaries are $140,000. That means we'd have to add up each one of these and set it equal to 140,000. Now, notice with my units, I didn't make this 21,000 and 14,000 and 140,000. I left off the $1,000, right? It'll be easier to deal with these numbers. Right, so we have this equation. It's a pretty simple linear equation, just combining like terms, right? Putting the number on one side, getting the variable on the left side. We end up with x is equal to 35. So now we have to say, what is the meaning of this answer in the context of the problem? That means that the education major median starting salary would be $35,000. We have to take that and add 21,000 to it to get 56,000 for the computer science major. Take that X and add 14 to it to get 49,000 for the economics major. Okay, let's take a look at another problem. In this problem, we're choosing between two texting plans. We see Plan A has a monthly fee of $15 with a charge of 8 cents per text. Plan B has a monthly fee of $3 with a charge of 12 cents per text. We have to determine how many text messages, will the cost of the two plans be the same. All right, well, the monthly fee is just like a flat rate, right? Here, though, this 8 cents for Plan A is per text. So it would make sense in this problem to let X equal to the number of text messages. Then we can write Plan A would be 0.08 times X plus 15, and Plan B would be 0.12 X plus 3. Right. The question is, for how many text messages will the cost for the two plans be the same? So we need to determine X when Plan A is equal to Plan B. if we just set each of these two equations here, set them equal to each other, and solve for x, I'll just work through this part here. So what I'm trying to do here is just get the variable on one side. I like to deal with positive numbers, that's why I subtracted 0.08. All right, and then I'm going to subtract the 3 to get it to the other side. So it turns out that x is equal to 300. So the cost of the two plans will be the same for 300 text messages. Here's another sampling of a problem you might encounter. All right. After a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the reduction? All right, what we need to do in this problem is, and this can be handled in a couple of different ways. One way to think of this would be, well, we're trying to find x, which is the price before the reduction. All right, how do we determine the cost of a new computer? So you have the original price. So think of the price before a reduction is the same as the original price before the sale. Okay, it's reduced by 30%. So then we take the original price, we take 0.3 times the original price, and we subtract the two. And that would give us the price of the new computer. All right. So here we purchase a new computer for $840. I have to set this expression equal to $840. Then the rest I think will be pretty straightforward for you. Notice these are both involving x. You can assume there's a 1 here. So that would be 0.7x is equal to 840, or I get x is equal to 1200. So the price of the computer before the reduction was 1200. Sorry if my handwriting it doesn't look as pretty as it does if I'm not writing, and usually it looks a little nicer if I'm not writing with a stylus, but that's just kind of a limitation of the stylus for me. But I hope it's at least it's readable or legible for you. Okay, let's take a look at yet another problem. So I've got a good variety in this section that I'd like you to go over because that'll make it more easier for you to do the homework. Okay, suppose now you inherited $5,000 with the stipulation that for the first year the money had to be invested in two funds, one paying 9% and the other paying 11% annual interest. You need to figure out how much you invested at each rate if the total interest earned for the year was $487. Okay, so we have $5,000. We have to kind of split this into two parts, but they're not equal parts, right? So let x be the amount invested at 9%. Okay, so, if it was $500, then, the amount invested at 11% would be 5,000 minus 500. All right, here, since we're not sure what x is, it's a variable amount. The amount invested at 11% would be that 5,000 minus x. If the total interest is $487, then we can write this equation. So what we have to do is we're going to take the amount invested at 9%, multiply it by 0.09. That's going to give us the interest earned at 9%. Then we need to take the amount invested at 11%, multiply it by 0.11, and that'll give us the interest earned at 11%. We know the sum of these two has to be equal to 487. As what was stipulated in the problem. Okay, what we're going to do is we just need to simplify the above and solve. So this stays the same. I have to take this 0.11, and multiply it by 5,000 and then multiply it by x, right, and subtract the two. So this would be the next line that we see. I can kind of combine like terms and then bring the constants over to one side, divide by 0.02, negative 0.02, and we'll get the x value. So the amount invested at 9%, remember that was our x, that's going to be $3,150. The amount invested at 11% is 5,000 minus that x, which is going to be $1,850. Okay, great. Here's a geometry problem. So we're going to encounter these problems a little later when we get to parabolas. So this is probably a good place to kind of start just to see one of these problems of this type. It's pretty simple actually in the statement. It says the length of a rectangular basketball court is 44 feet more than the width. If the perimeter of the basketball court is 288 feet, what are the dimensions? This would be a problem where I would probably use different variables instead of just using x. So I think it makes more sense here to represent W as the width of the court. Let me just slide down to the original problem. And then the length of the court, because of this, the first statement says here, it's 44 feet more than the width, would be W plus 44. The perimeter of the court is 288 feet. So you want to come up with that equation for perimeter. Remember, if this is the court, it's going to be 2W plus 2L. And I'm going to substitute in for perimeter. So this is my P. This is my 2W. And I'm going to substitute in for L as W plus 44. So what we want to do is, even though I used two variables here, I would just like to write our equation in terms of one of the variables. We're going to distribute this 2. And once we distribute the 2, we get this equation. And then just simplifying, I get W equals 50. So the width of the court is 50 feet. Remember, the length was W plus 44. So the length is 94 feet. And then the dimensions are 50 by 94 feet. Okay, the second part of this section is about solving for a variable. So what we want to do is you're going to be given a formula, and we just want to isolate one variable on one side of the equation. So let's take a look at the problem 6 here. We've got a simple formula. P is equal to 2L plus 2W. Well, you've just seen that. That's the formula for perimeter. Notice that we're going to solve for W, and it only occurs once in the equation, because we'll see in problem 7 a different situation. So we just want to isolate the term containing the W on one side. So I want to get 2W by itself. So what I did was I just subtracted 2L from both sides. And then I'm going to divide by 2. So I'm just going to keep the W on this side. I could have written it as W on the left is equal to that, but this is perfectly fine. All right, so that was pretty simple. Let's take a look at problem 7 and how it differs. Okay, kind of a similar equation in a way, except C, all right, occurs twice in the equation. If this happens, if you encounter this situation, you need to factor it from each term on the right-hand side, the variable that you're trying to solve for. So I need to pull this C out. I need to isolate it. I want to get it by itself. I'm going to keep it on the right side. So if I factor out the C, that means there's a 1 here, right? So imagine taking out this C, that means there's a 1 left plus M, and the P is on the left. If I were to multiply this back, we would get the same thing on the right. Next, what I can do then is now I can divide by 1 plus M on both sides. The 1 plus M's will cancel out, and I'm left with C is equal to P over 1 plus M. Okay, let's see another problem. This is kind of involves least common denominator. So we've got this situation now. We've got some fractions here, some rational expressions, and we need to solve for F. Now this is one way to solve for it. You might come up with another way that's easier. What I can do is I can think of what is the least common denominator in this case. Well, each of these variables are distinct, they're different, so I need one of each type, the product. So the least common denominator is going to be PQF. So I'll multiply PQF on both sides, right? If we notice, and then I have to distribute. So let's take a look at the right side. The F's will cancel, and I get PQ. Here we see that I'm left with QF and PF. Now we're back to the situation as in problem 7. So in problem 7, since I see this variable occurring twice on the left side, and that's the thing I'm solving for, after I basically cleared the variables by multiplying by the least common denominator, I factor out the F on the left side, and then I divide by Q plus P on both sides, and then our final answer is F is equal to PQ over Q plus P. Okay, we're finished with this guided worksheet, and why don't you get started on your homework, and then you can take your quizzes. Good luck in this section, and let me know if you have any questions. Just email me.